Hello and welcome to Mr. Clee's second video for Chemistry Unit 6, Chemistry Out There. This is about the electrolysis of aqueous solutions. Please look out. At various times you'll see the pause sign on this presentation. That's to indicate that it might be a good opportunity for you to have a go at a question, something that I'm later going to go through in the video. So there's a very strong link in this video to the previous one, which was electrolysis of molten electrolytes and water. This is about what if you've got a solution, and we should be able to write half equations for the electrode processes that are going on and to carry out some simple calculations in terms of linking the amount of product formed in an electrolysis to the time that it runs for and to the current that's used for the electrolysis. Firstly, whenever possible, electrolysis of aqueous solutions takes place instead of that of molten solutions. This is because you don't need the high temperatures involved in molten electrolysis. In aqueous electrolysis, it's much simpler to achieve in a laboratory. However, sometimes when electrolysing something in water, the products that you get are not exactly what you might expect. Here is the example of aqueous copper sulfate. Copper sulfate is blue liquid, and in aqueous copper sulfate you should be able to see the copper forming at this electrode here. That identifies that electrode as the cathode. You should be aware by now that copper is a positive ion. Therefore, as a positive cation, it is drawn to the negative cathode. Oxygen, you might just be able to see bubbles of oxygen forming at the anode here. Oxygen is a negative ion, therefore it's drawn to the positive anode. Stands to reason that the longer this experiment runs for, the more copper you'd expect to get. Also, the higher the current used, again, the more copper you'd expect to get. There are two examples here where we can link the current and the time that an electrolysis runs for to the amount of copper that's produced. In the first example, using 1 amp for 60 minutes produces 1 gram of copper. So how long will it take to produce 3 grams? The way to do this question is in effect to say what current is made per hour. So it's 1 over 1 equals a rate of 1 gram per hour. So if we've got 1 gram at 1 amp, you get 2 grams in 1 hour at 2 amps. We require 3 grams, so we do 3 divided by 2, which gives you 1.5 hours or 90 minutes. If you're trying to make 10 grams, then in this situation we need a rate of 2.5 grams per hour. So if we're running it for 4 hours, we need 2.5 grams per hour, which, because it's 1 gram per hour, is 2.5 amps. Right, this is the point where this part of aqueous electrolysis gets complicated. In effect, in this solution you have two positive ions. You have hydrogen ions and you have copper ions. And the product that's formed at the cathode depends on which is the most reactive of these ions. In this situation, because copper is less reactive than hydrogen, the copper will be formed at the cathode and the more reactive hydrogen will stay in solution. If this metal was more reactive than hydrogen, then the less reactive hydrogen would be formed at the cathode and the more reactive metal would stay in solution. This can be summarized simply in this table. If it's more reactive than hydrogen, then hydrogen gas will be formed in the electrolysis of an aqueous solution containing that positive ion. And if it's less reactive than hydrogen, then the metal will be formed. That will probably only really apply to, in practice, in exam questions, copper. There's a small chance of them asking you about silver, but in effect, in an aqueous solution, you'll usually get hydrogen formed. There's another rule to remember at the anode, at the positive ion. In an aqueous solution, oxygen will always be formed unless chlorine is present. So in these three situations, potassium nitrate, sodium hydroxide and sulfuric acid, Because in this one no metal is present, hydrogen is formed, and no chlorine is present, oxygen is formed. In this one, sodium is more reactive than hydrogen, so hydrogen will be formed, and so will oxygen. Potassium nitrate, potassium is more reactive than hydrogen, so hydrogen will be formed, and oxygen. It's only when you get to the top two examples, with copper sulfate, which we've already seen, copper is formed at the cathode, and oxygen at the anode, and copper chloride, where because of the presence of chlorine we now get chlorine produced at the anode, and because copper is less reactive than hydrogen, it is produced at the cathode. Might want to try these questions before I go through. Remember, in all examples the cathode is negative, so positive ions form here, and the anode is positive, so negative ions form here. Hydrochloric acid, hydrogen is present but no metal ion, so that forms at the cathode. Chlorine is present, so that forms at the anode. In copper sulfate, as we've already said, copper is less reactive than hydrogen, so it forms at the cathode, and there is no chlorine present, so at the anode we have oxygen gas. In potassium nitrate, potassium is more reactive than hydrogen, so hydrogen gas is formed, and there's no chlorine present, so oxygen is formed at the anode. Higher tier candidates need to know how to construct half equations for the processes going on at the electrodes. Half equations usually just involve one ion and one product. So if we take, for example, formation of chlorine gas at the anode, the first thing to do is to identify the ion. Chlorine gas, a chloride ion is Cl-. At the anode, chlorine gas is produced. So we have chloride ions forming chlorine gas. Currently, after the reaction, we have two atoms of chlorine joined together, and beforehand we only have one chloride ion. The first thing to do is we need to add in a 2 to say that we have two chloride ions, which will eventually form our chlorine gas. At the moment they have charge, so there's an imbalance in the number of electrons that are present. To figure out the number of electrons, you need to multiply the number of ions by the charge on each ion. So 2 times 1 gives you 2 electrons. To work out whether these electrons are gained or lost, there's a little trick that you can use. Because it's negative, you're going to need to lose electrons to make it overall electrically neutral. But the little trick is that whatever this sign is here, positive or negative, you must do the same here. So this is a negative sign, therefore you must take away those electrons. If that was positive, you'd then add those electrons. So these two signs there must be the same as each other. Final thing you need to do here is to add in state symbols. The chloride ions beforehand are aqueous, and after a gas is produced. Some good examples of questions to practice here before I go through them. Firstly, copper 2+ forming copper. Here we have 1 and 1, one ion, one atom. So, because that's a positive sign, we're adding in 2 electrons, because we've got a charge of 2+, and that gives us copper. Hydrogen forming during the electrolysis of aqueous potassium nitrate. We've got our hydrogen ion forming our hydrogen gas. Our hydrogen ion, there is one of it, and there are 2 atoms in the diatomic hydrogen gas. So we add a 2 in there, that tells us that we have 2 electrons, and because this is a positive sign, we're adding those electrons in. Putting in state symbols, hydrogen and copper in both these examples will be aqueous, copper metal will be a solid, hydrogen gas would obviously be a gas. Chlorine forming at the cathode, which is incorrect. Chlorine forms at the anode. We have chlorine gas is formed from chloride ions. We require 2 chloride ions, losing a total of 2 electrons to form chlorine gas. Again, the chloride ions would be aqueous and the chlorine gas would be a gas. The trickiest one is oxygen formation. Oxygen is formed from hydroxide ions. These hydroxide ions need to lose electrons, but as a byproduct, water is formed. In order to complete this, what you have to do is make the number of hydrogen and oxygen atoms present on the right hand side the same as each other. The way you do that is have 2 water molecules form, giving you a total of 4 hydrogens and 4 oxygens. That means we can balance it by putting a 4 on that side. This then tells us that if we've got 4 hydroxide ions that are negative, we need to subtract 4 electrons. Putting in the state symbols, hydroxide ion will be aqueous, water is a liquid, and oxygen is a gas. That concludes the video. There's some summary points here about when we get hydrogen, when we get a metal produced. Essentially, if the metal is less reactive than hydrogen, then the metal is produced. If it's more reactive, then hydrogen is produced. At the anode, it is always oxygen unless chlorine is present. Please remember the steps for half equations. They are the trickiest part, but will come up on any higher tier question. Use information in questions. You can usually collect 1 mark by putting the information down in an equation, and balancing it gives you the 2nd mark. If you've got any further questions, please see myself or any of you science teachers for further assistance. Thank you.